We're going to be reviewing question 9 that came in paper 1 for Limpopo. So we're given this configuration here, which comprises a square and a triangle, and there are questions that follow from there. So let's get to it. Okay, so the figure below, ABE is a mounted triangle. ABE is mounted on a rectangle BCDE. Well, we know properties of a rectangle, right? Opposite sides are equal as long as it's a rectangle. So if here it's y, the side opposite to it will also be y, and the side opposite to that one will also be x. So that's what we have for now. And let's see. The base and the perpendicular height of the triangle add up to 10 meters. Okay. So the base and the perpendicular height of the triangle. So where's the triangle? The triangle is here. So that is our triangle over there. So basically, if I take this and this, they should add up to 10, right? So that's the first expression that we have. We know that x plus h is equal to 10. Y is the breadth of the rectangle. Okay, we see that. Okay, now let's see. Show that the area of the area of ABCDE, which is this whole thing over here, can be represented as a of x equal to negative x over 2, 3x minus 42. Now let's call this rectangle section 1, and let's call the rectangle section 2. Now there's no formula for calculating all this at the same time. So what I will say is that the area of A, B, C, D, E is equal to the area, okay, let me say, it's equal to the area of ABE plus the area of BCDE. So basically, it's equal to the area of a triangle plus the area of a rectangle. I'm going to break it stepwise. But now if you check here, the second one is already easier, right? So now let's say what is the area of a rectangle BCDE. It's given by length multiplied by breadth, right? But the length is x and the breadth is y. So basically the answer is just xy. Okay, now this is area as a function of x and y is equal to xy. But we only want area as a function of x, not y. So we have to find a way to remove this y. But for now, let's leave it like that. Now let's move to the triangle on top. Well, we know that the triangle, the area of a triangle is generally given by a half multiplied by the length of the base times the length of the height. Well, I'm going to have half multiplied by, now what is my base? My base is here. This entire thing here is my base, which corresponds to x, right? So it's x multiplied by h, which is the height. So the height of this triangle over there is that. But we know from this expression that x plus h equal to 10. This means that h is equal to 10 minus x. Well, I can come here and on the space of h, I replace this with x minus 10. Okay, since we say from here that h is 10 minus x, 10 minus x. Now this means that we have half multiplied by x multiplied by 10 minus x. Well, if we do that, I'm going to end up with half multiplied by 10x minus x squared. Now this is the area of a triangle. Okay, Well, let's see. Let's go here and see what we can do. Well, if you can check here, the perimeter is 32, right, of the rectangle. Now, what does this mean? Well, the perimeter is the sum of all the sides, right, that are given in your shape. Now, this is the perimeter. Now, this means that x plus y plus y is equal to 32, right? So now, if you do that, you're going to end up with 2x plus 2y equal 32. Now, if you divide that, you end up with the expression x plus y is equal to 16. Okay, because x plus y is equal to 16. Well, from there, what are we going to do? Well, our aim is to calculate the area in terms of x alone. So here, I'm going to come and remove this y from the area expression. So I can say y is equal to 16 minus x from here. And I'm going to come and put this where there's y here. So basically, this means that area as a function of x, which was xy, is now equal to x multiplied by 16 minus x. Well, let's see what we have there. I'm going to have 16x minus x squared. Okay. Now, this was the area of the triangle. It was for the rectangle, right? So this was for the rectangle. And this one on top here, it was for the triangle. Now, to find the total area, I have to add the two areas. So the total area is equal to 16x minus x squared. Now, let me just distribute this one inside, right? So a half multiplied by 10 is going to be positive 5x, and a half multiplied by that is going to be minus a half x. Well, if I do that, I have 16 plus 5, right? So if I add 16 plus 5, I get 21. And what is negative 1 minus a half, right? So if we say 1 plus a half, we will get 3 halves. So it's minus 3 over 2 x squared. Now this is the area as a function of x. But your aim is to write it in this way with only half on the outside, right? So how do you do that? Well, if I pull out, if I divide everything here, or I take out a common factor of negative a half x, here, what should I put? What number should I multiply by 20 by half to get 21? It turns out that is 42, right? So 42 multiplied by half is 21. So here I must put negative 42, right? So I must put negative 42 over there. And then here I took out a half, I'll be left with positive 3x squared, right? So now if we check here, actually it's 3x because 1x is already on the outside. So if you check, this is what we're required to do. So this is the same as negative x over 2. If I write the inside, I can write this as 3x minus 42. And we have successfully placed it in the form in which they wanted us to put it. And this was 4 marks. So this is how you do it. The first step is to gather all the information and try to express the area in terms of x alone, since they want it in terms of x. And from there, you'll be fine. Now, calculate the value of x for which A, B, C, D, E will have a maximum area. Okay, so what can we do? For us to have maximum area, you must know this from calculus. For maximum area, the derivative of something, which in this case is a function, derivative of something must be 0, right? And then you solve for x using the expression that you found on top there. But in the previous step, we found that a of x is negative x over 2 multiplied by 3x minus 42. Well, remember that this expression here is representing the area of this whole thing, right? So if any value of x will give us the area of that. But now one the value of x specifically that will give us a maximum. Well, what I'll do is that I'm going to write this thing like this so that I can differentiate it. So I'm going to write it in this way. S21 minus 3 over 2 x squared. Right. So this is what we have over there. Okay. So this like that, right? So this was an x here. So 16x plus 5x. Okay. So now let's see. So here there must be 21x. The expression is like this. Now let's differentiate the area with respect to x. Now recall the rules of differentiation. If I differentiate a function that has a power a, I take the power to the front and I subtract 1 from that power, then I find my derivative, right? And if I have a derivative of a constant b multiplied by f of x, which f of x is a function, I keep the constant and I differentiate the function. Now, these are the rules which we are going to use to be able to differentiate a with respect to x. Now, I can write this in this way. I can say d over dx of a of x, or I can just say a prime x. They all mean the derivative. Well, now, examine this first part over here. I've got a constant and a function. Now, what is the derivative of x with respect to x? It's 1, right? Because it's d over dx of x, which is the same as dx over dx. You can think of it as dx cancelling dx to give you 1. Well, I'm going to keep my constant, which is 21, and I differentiate x, which will give me 1, minus 3 over 2 is a constant, right? So I'm going to keep it out of the derivative, and I'm going to differentiate x squared. Well, remember the power rule. When I differentiate x squared, I have to take the 2 and move it to the front and subtract 1 from it, right? So I'm going to have 2 multiplied by x to the power of 2 minus 1. Then my a prime is going to be 21 minus, well, the 2 will cancel the 2. I'm left with 3x. For me to find the derivative, I must always equate to 0, right? The way we did here. The derivative of something must be 0. But in this case, the derivative of the area must be 0. Well, if I rewrite this expression, I'm going to have 21 minus 3x equal to 0. I move the 3x to the other side. I'm going to have 3x is equal to 21. Divide everything by 3. It turns out that your x is equal to 7. Well, this value of x of 7 is the value of x which will give you the maximum area when you put it inside this expression over here. And this was 2 marks. Okay. Now let's move on to the last one. 9.3. Calculate the maximum area of ABCDE. Well, now what is happening now? Well, I've got C, right? I've got A of x is equal to 21x minus 3 over 2x squared. And I know that the value of x of 7 will give me the maximum area. Okay, well, this is the area and this is just the value. This means that if I put the value of 7 into that formula, I'm going to get my maximum area. So basically, I have to find A of 7, which is equal to 21 times 7 minus 3 over 2 multiplied by 7 squared. And let's see what gives us. Well, I'm going to have 21 times 7 minus 3 over 2 multiplied by 7 squared, which will give me 73.50 squared meters. Remember, the units for area is square meters. So, well, how can we prove that in this case 7 will give us the maximum area? Well, let me do this. Let me take number 7 and take 2 numbers on top of it and 2 numbers below it and calculate the area for each of these. Well, this is just for illustration. You don't have to show this, right? So A of x is equal to 21x minus 3 over 2x squared. Okay, that's what we know for now. So Now, if I put 5 on the space of x, I'm going to have 21 times 5 minus 3 over 2 multiplied by 5 squared. If I put that on a calculator, I'm going to end up with 67.5. Well, if I now put 6, let's see what we get. When we put 6, we get 72. Right. When I put 7, I already know it's what we got there to be 73.5, right? So the answer, when I put 7 here, I get 73.5. Well, let's put 8 and see what we get. Well, if I put 8 on the space of 6, I'm going to get 72. Well, if I put 9, I should get the same answer as that one. But let's just see if it turns out to be that way. Because it's a parabolic function, so it is symmetrical on either side of the line of symmetry. Well, I get 67.5. Well, now, what do you observe here? The area is increasing as you move from 5 to 6. But when you get to 7, it reaches a value 73.5. From there, it starts decreasing again. Well, if you were to plot this on the graph, this is what you will do. You will say that your index from, let's say they're coming from there, then it's 5, 6, 7, 8, 9, 10, 11. From 5, 6, 7, 8, 9, 10, 11. Well, these values are increasing as you move, they reach to 7, and then they start decreasing again to the same spot. Now, if you can check, at 7, this is where we have a maximum area. So this is what you were required to prove here, that when the value of x is 7, then you will have a maximum area. And this is how you can solve such a problem. Feel free to leave a comment in the comment section if anything doesn't make sense, and more than free to assist. Thank you for watching.